I have a second channel, Cube Comp MTDX. Hey everybody. So this is the second video about this particular power supply here. If you didn't watch the first video, let's go ahead and do a little quick little review. So this power supply came out of a computer I cleaned out yesterday. It's my neighbor's computer. Went over and got it the day before yesterday, or pretty recently, to service it and upgrade it. And I took it out yesterday, I think it was yesterday, to clean it out. And well, I went to plug the computer in, and as soon as I plugged in the power, bam! Sound like fireworks, and I guess it's appropriate for being Memorial Day. But this thing, I saw a quick little fireball and immediately jerked the plug out of the back of it, and smoke went everywhere. It didn't smoke too bad, but it did stink up the room quite a bit. And I opened it up in a previous video, and I found out that there was a black spot right next to the 5-volt standby transformer. And it's just really weird, because this thing was working fine up until this incident. So I'm wondering if perhaps it was when I was blowing this thing out with the rest of the computer with the air compressor, maybe there was a piece of solder up under the circuit board that got dislodged and shorted something out, or maybe the glue. I did mention the glue in this thing can become conductive when it gets heated up and when it darkens. That's a possibility too. So what we're going to do in this video is we're going to tear this thing down and see if we can figure out what happened. What exactly went wrong here? Okay, so I got the soldering iron heated up, so it's ready to go. I'm going to pop this zip tie here, and of course I will not be repairing this thing, obviously. If it weren't for the damage that happened, I probably would be recapping it, because it has some failed caps in it. These Bestec units, they never seem to use the right capacitors. They used Jamicon for many years, and then they used TPO and sometimes OST. The units with TPOs, or Capzon, excuse me, they use Capzon quite a bit. The units with Capzon, Jamicon, and TPO, it wasn't uncommon for them to experience capacitor issues. And the Bestec ATX-300-12E, when the caps failed in it, the 5-volt standby rail the voltage would go way out of spec and fry your motherboard. That's why many E-Machines computers from around 2001 to 2005, that time period, that's why they had a lot of reliability issues. But this is actually a Bestec ATX-300-12E, which is not affected by that issue, but it definitely does have some problems, and it still smells awful. You can still smell it. So here's a look at the underside of the PCB. So it definitely was not caused by anything under the circuit board, but rather on the top side. So let's go ahead and remove the screws for this switch here. That way the switch can come out. I'm going to desolder the power socket, or not the power socket, but the power leads, and also going to be getting rid of these wires too at some point in the process. Matter of fact, I might go and do that now. I think it'd be a little bit easier to do it now while the power supply is still in its casing. So we'll go ahead and pop the zip tie right here. Okay, so this switch has been detached. See, I could, if I wanted to, I could reuse this power supply case for something else if I wanted to. Probably won't. Who knows? I do like how this particular Bestec model uses a clamshell case, whereas most of them has the conventional lid on the top. This one just has the C-shaped clamshell that slides off. Okay, so let's locate our two power wires. So we have, yep, this is the two power wires, a live and a neutral. We'll go ahead and detach those. Just gotta figure out where they are. Do the best I can here. There's one of them, and here's the other. Okay. Now the power wires are going to be a little more tricky because of the way that they're soldered in, but let me see what I can do with them. Okay, so the output wiring is completely out, so now we'll go ahead and unbolt the main PCB from the chassis. Just about forgot I gotta disconnect the fan, which on this one is apparently it's just soldered on. So I'm just gonna I'm gonna snip the wires because they're kind of concealed by the yellow glue, and I don't really feel like having to deal with that. So, fan wire is disconnected. Now, let's go ahead and unbolt this thing. Okay, so now the circuit board's completely out. And before I really tear into this thing, I'll give you guys an opportunity to have a good look at it. So, that's the Bestec ATX-300-12E Power Supply PCB with all the goodies still intact. So the failure spot was right up inside here. Not sure if you can actually see it from that angle of view, but it was right next to this 5-volt standby transformer and next to a 8-pin integrated circuit right there. So essentially what we're going to do is we're going to remove this 5-volt standby transformer to get easier access to see exactly what went wrong. So what I'm doing now is I am going to be removing both of these heat sinks and components to gain easier access to these two transformers. So I got to remove this solder. That way I can get these components broke loose. Now there's at least two ways you can do this. You can do it with the solder sucker like I'm doing, or you can use a desoldering braid. So I'll give you a quick example of desoldering braid. Desoldering braid this method can be a bit more time consuming because you're having to heat up the solder along with the desoldering braid. But this method you would typically use for removing smaller amounts. If you're wanting to remove larger quantities, I always like to use the solder sucker. A little bit of force is all you need. So there's our main switcher. Now see markings FQA9N90C. Okay, so we got the primary heatsink out of the way. I think I'm going to go ahead and remove this secondary one. Now there's a lot more stuff on the secondary heatsink, so it would be a little more time consuming. Okay, now the secondary heatsink is out, as well as the rectification diodes for the secondary side. So that leaves us with the transformers in the center. Now we have easier access to them. So we're going to pull out this standoff. So I think our plan of attack here, the best method would be to take out the primary transformer and then the secondary transformer. So I'll get rid of this glue here. Okay, so the main transformer is out. This particular transformer is in charge of the primary rails, like your 5-volt and your 12-volt. And I also believe your 3.3 volt on this one. And this one here, I believe, is in charge of just a 5-volt standby. So the more we rip into this thing, the closer we can get to the to the source of the problem, which is right inside here. So let's keep going. Let's go ahead and take out the second transformer. Okay, guys, now we're going to be taking out this transformer right here. This is the one where the issue occurred at. Okay. Alrighty, guys, I think we may have found our culprit. So you can see exactly where the problem is now. And let's have a close look at this transformer. So I do think it was the glue. The glue in this power supply. With time, it got hot and it got corrosive. I mean, not corrosive, but it got conductive. You can definitely see the mess that it left on that PCB. I mean, it left a big mess. Now, if I had left this plugged in, it would have made a much bigger mess. It probably would have, yeah, it would have been a lot worse if I would have left it plugged in. I'm kind of wondering if perhaps that glue shorted not only some terminals out on that transformer, but also the, try to point it out to you, that IC right there. If you look at the, let's see what pin, that'd be pin 8, which on the video will be the upper right corner. That's where that glue was touching too. It's like the glue, with time, in that one spot, being a hot spot next to that resistor, that glue got hot and it got conductive. So, isn't that crazy? Let me find the meter. Let's see if I can get a resistance reading across that. Attempt to, anyway. I don't think the transformer itself shorted. I think it was actually the glue. It got conductive with time. Now, let's see here. It's really bizarre, guys. I'm not getting a reading on this. Let me try a higher scale. It's interesting. The resistance reading is so high right here. It's really weird. I kind of want to say it was the glue. That's all I can think of, unless a piece of something got in there, and perhaps when it shorted out, it just blasted it completely out of there. I'm not sure, but you can definitely see the black spot where it where things blew up. Get you a close up there. Sorry guys, I'm got this at a kind of an awkward angle here. There you go. I can't be 100% certain on this, but I'm willing to think the glue may have been part of the problem. That glue got hot, it darkened, and it got conductive, and eventually it caused a short circuit. Like I say, I'm just not 100% certain on that. Exactly what happened. I mean, it left a big, it left a nice blast, and I'd tell you, it stunk on it sure did stink up the room when it happened. So, anyways, I guess I'll go ahead and end it right here. So, that is a better look at what failed in this power supply. Not something you see every day, and I don't think it's really an issue with all these power supplies. Matter of fact, the power supply I put back in this computer is another 312E, and it's working fine. Knock on wood. I've used these things and reused these things for many years without any issue, other than having to replace caps. You can see this one's got lots of failed caps on it. Well, I can't say the only caps that haven't failed are this KZE Chemicon, because there are some Jamicons on here that are okay, but the Jamicons are subject to fail, as well as the Capzons. This one's got Capzons on it. Yeah, I see. The primaries are Capzon. Well, they've used Capzons on the primaries for years, but it seems like the Capzons over in the secondary side, they tend to go. The Jamicons tend to fail. The TPOs, whenever they use them, they tend to fail. Sometimes if they use OSTs, they might fail, but they generally tend to be a lot better off. The Jamicons do seem to last a decent amount of time. I mean, like 5-6 years before they really start to have any issues, but they do eventually let go. And so anyways, I guess that wraps up this video. I'm gonna finish tearing this thing apart. I always save like these primary caps, that bridge rectifier, these filtering components, and all that good stuff. So anyways, hope you guys enjoyed this video. Thanks for watching. Well, everybody, that's it for this video. But don't forget, there's a lot more interesting stuff on the channel to check out. Also, if this is your first time visiting this channel, feel free to subscribe to keep your channel. And also, don't forget to tick the bell so that way you'll get notified of new video posts. If you like this video, please give it a thumbs up. But if you really didn't like it, there is the alternative option available as well. Also, feel free to check out my second channel, CubeComp MTDX. There you'll find videos about bicycling, weather, elevator tours, and all sorts of other neat, interesting stuff. I hope you guys enjoyed this video. Feel free to come back, and thank you for your support.